In this video, we're going to be looking at how to calculate the pH of strong acids. But before we get into the math, let's review how to classify a solution as acidic, basic, or neutral. Here's a list of strong acids and bases, and you may have noticed a pattern here. Acids have H in the formula. So notice that all these formulas have H in them. And the bases tend to have OH in their formula. And just to jog your memory, remember, we looked into electrolytes versus non-electrolytes last week, and we've learned so far that strong acids and strong bases are strong electrolytes, which means that they're going to completely dissociate when they're dissolved in water. So what that looks like for a strong acid like hydrochloric acid is that you have HCl completely dissociating into H plus and Cl minus ions. Remember, you have a positive and negative dissociation. On the other hand, a strong base is also a strong electrolyte that'll dissolve like this. So let's take lithium hydroxide for example. Lithium hydroxide will dissociate as such. Lithium, and that's a metal, gets a positive charge, and then OH is the anion, and that gets a negative charge. So this is how your strong acids and strong bases will dissociate. Another way to differentiate between acid, neutral compound, or base, apart from just looking at the formula, is to look at the concentration of H plus and OH minus ions. So let's look at acids. When a compound is an acid, it will have more H plus ions than OH minus ions. So acidic solutions have a greater concentration of H plus ions. And what that'll look like if you have an aqueous solution is you have a bunch of H plus ions floating around the solution, very few OH ions. So you have more H pluses floating around in the solution than anything else. A neutral compound will have an equal concentration of H plus and OH minus ions. So they kind of cancel out if you look at it. So what that'll look like is just like water. Water is a neutral solution, so it'll have an equal concentration of H plus and OH minuses. So they will be very balanced or canceled out. There's nothing more than each other. A base will have a greater concentration of OH minus ions. So OH concentration is greater than H plus concentration. And what that'll look like in a solution is you have a lot of OH minuses and very few H plus ions in solution. So these properties are what gives acid pH of less than 7. This is what gives neutral solutions a pH of 7, and that's why bases have a pH of greater than 7. So pH less than 7 means there's more hydrogen ions. pH equal to 7 means there's an equal concentration, and bases which have a pH of greater than 7 means we have more OH minus ions in solution. Alright, so let's dive into the math. First things first, the formula for pH is written as pH equals negative log of H plus concentration, or written as pH equals negative log of hydronium ion concentration. Make sure to write this down in your notes because these formulas will be very important as we move along. So you notice we have two formulas. They're basically the same thing because H plus ions are the same as H3O plus ions. So whether you see them written as H plus, H3O plus, they're the same thing. Hydronium ion, hydrogen ions, basically the same concept. So the first question asks, What is the pH of a 0.14 hydrochloric acid solution? So we're being asked to find the pH, and we're given the concentration of hydrochloric acid. Since hydrochloric acid is a strong acid, we can assume that the concentration of HCl is also going to be the same concentration as H+, because HCl completely dissociates in water. So it'll be the same concentration. Therefore, we have our concentration needed to plug into our formula. Now we just take the pH formula and plug it in. So pH, what you're going to type into your calculator is negative log, open parentheses, put in that 0.14 molar. That's your concentration. I'm sorry, the way you put in your calculator, you won't put M, you just put 0.14, and the answer you're going to get is 0.85, and you can always round to the nearest few decimals. The next question asks, an unknown solution has a H+ concentration of 1.3 times 10 to the negative 5 molar. Does this solution contain an acid, base, or neutral compound? So first let's take care of the, let's look at what we're given and what we're being asked to find. We're given the H+ concentration straight away. This is that value. It's asking us to determine if it's an acid, base, or neutral compound. How can we tell if it's an acid, base, or neutral? We calculate the pH. So let's go ahead and calculate the pH, plug in the numbers. So in your calculator, you're going to type in negative log. And the way this will go into your calculator is that you will type in 1.3. And there's a feature on your calculator that lets you, it's the letter E. So 1.3 E, and then type negative 5. That's the same thing as 1.3 times 10 to the negative 5. Or you can just literally type in 1.3 times 10 to the negative 5. Whatever way works for you. This is just a shortcut. Plug in that number, and your answer should give you 4.89. So just round to the nearest few decimal points. Now, 4.89 is our pH. How can we tell if this is an acid, base, or neutral compound? Remember, an acid has a pH of less than 7. Neutral has a pH of 7. And then a base will have a pH above 7, greater than 7. So with these parameters given, how would you classify this? We'd classify this as an acid because 4.89 is less than 7. So our solution, our known solution, is an acid. So the summary of what you need to know for pH calculations is that the formula for pH is negative log of your H+ concentration. Keep in mind that H+ is the same as H3O+. Also, you need to know that an acid has a pH less than 7. Bases have a pH greater than 7. And neutral solutions have a pH of equal to 7. So now you can move on to the next few examples and try them by yourself.